So let's now take a look at the axis of symmetry. This is a special line that literally cuts our parabola right in half, and it runs up and down through the vertex. So let's take a look. So now let's talk about something called the axis of symmetry. Now you guys, if you look at a parabola, it is beautifully symmetric, right? We could literally cut that parabola in half, and if we reflected it, it would be the same on both sides, okay? And when I talk about cutting that parabola right in half, right? So if we just drew a line and then cut it on that line to cut it in half, I'm actually talking about the axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. So I'm talking about the line through which this parabola would be symmetrical. And your axis of symmetry always goes through that vertex. It's always going to go through that like center point, okay, which should make sense. If we want to cut it in half, we have to cut it right down the middle. The vertex is the point at the direct center of our parabola, right? At least on the graph of our parabola, I should say. And so this axis of symmetry is that vertical line that's going to go through the vertex. It's the line that's going to cut our parabola in half. Well, we can also say it's the line that is of x equals negative b over 2a. That should look really familiar, right? We just used this formula, negative b over 2a, to find the vertex, this point right here, to find the x coordinate of the vertex. All that's saying is that the axis of symmetry goes through, it's the line that goes through the x coordinate of that vertex, right? It's the line that's going to go right through, right there. It's going through the x. See how it hits the x-axis? It's a line. That's why our line is x equals negative b over 2a, because it's that vertical line that's going through the vertex, okay? So it has to have the same x value as our vertex. So if we are trying to figure out what the axis of symmetry is, let me show you again. How would we do that? Let's look at the same example we've been working with. This function, y equals x squared minus 10x plus 19, okay? And I told you the first thing you always want to do before you start graphing your quadratic function, your parabola, is you always want to identify your a, b, and your c, right? We know that a equals 1, b equals negative 10, c equals 19, but it bears repeating. You should always, always, always find those first. Okay, if we want to find the axis of symmetry, we know it's the line x equals negative b over 2a. Again, let's plug in negative 10 for b, 1 for a, and what does that give us? No big surprise here, x equals 5, okay? We don't have to go any further. The axis of symmetry is not a point, right? Our vertex was a point, so we needed to find a y coordinate to go with it. This is just a line. It's just the line x equals 5, okay? So the axis of symmetry is the line x equals 5. If we look at our graph, there it is. Axis of symmetry, x equals 5. So it's just this line that cuts our parabola in half. So if we reflected our parabola over that line, we would get the whole graph, right? It'd be identical from one side to the next, okay? It's symmetrical. It's the line that makes our parabola symmetrical. That's why it's called the axis of symmetry, okay? And it will always go through the x value of your vertex, okay? Notice we got our vertex here was 5, negative 6. Well, the axis of symmetry is just the line that goes through x equals 5, okay? Because of course it has to go through the vertex, right? Our vertex is right smack dab in the middle. All right, so that is the axis of symmetry. Another very important piece of our graph. So if you are so far following along, you understand how to find these coefficients a, b, and c. You understand how to find concavity. You know, if it's concave up or concave down, if you're dealing with a maximum or a minimum. You understand what the vertex is talking about and how to find it, and the axis of symmetry and how to find it. You can just totally skip this slide. You can jump ahead to the next slide, okay? If you would like some more practice, okay, because I know I just threw a ton of information at you. So if you want some more practice, you can use this slide to do so, all right? You can pause it. You can look. I put 3 different quadratic functions here, and I wrote in the information for you what the a equals, what the b equals, what the c equals, what the concavity is, if it's concave up and we have a minimum, or if it's concave down and we have a maximum, how to find the vertex and the axis of symmetry. So if you are still not comfortable with any of those pieces, I would pause right here, start at the first function, okay, and just see, where did this 1 come from? Where did this 4 come from? Where did this -3 come from? Oh, wait, right. This must be concave up because our 1 is positive, our A is positive, so we're dealing with a minimum, okay? How did I find the vertex? All right, here's my x-coordinate of my vertex. Here's the y-coordinate of my vertex, all right? So here's my vertex. And the axis of symmetry is, of course, the line that goes through that x-coordinate. So if you are not sure, pause here, go through each one of these, work through them. The answers are right here in front of you, and this will just give you a little bit of extra practice, okay? Once you're done with that, unpause the video and move on and listen to the rest of the slideshow.